The reality is that a storage processor has to do certain things within the storage environment, within that storage array. Some of them we're listing up here: remote copy, management, boot, SSD. We'll talk more in detail here as soon as the animation grows up. And then in addition to that, the storage processor in many environments, those without an application-specific integrated circuit, have to also do these things: thin and fat provisioning, other nodes, right? Some sort of mesh to talk to other nodes, and zero reclamation. All of these functions have to happen within a storage array. They have to occur in order for that storage array to do its functions within the environment. And so we have, in many environments, we only have storage processor or processors. But here we're talking today about an environment that has a controller and an ASIC, an integrated circuit board. And so when you look at storage arrays, this is what you're looking for. Because the reality is you're going to have to do all of these processes listed on your screen today within your storage array. Doesn't matter whose storage you own, you're still going to have to do these things. So let's walk down through each one of these and talk just for a moment about each one of these functions that occurs within a storage array. But before we go there, think about this. Years ago, when storage arrays, many of the storage arrays that are in our environments today were built, they were built on the requirements of 10 years ago, which was primarily block and file storage. Today, we have so much more that we do within our storage environments. So, can an existing storage vendor without an ASIC provide these functions? They can, but they're going to have to get that horsepower from somewhere. So what does that mean? That means environments without an ASIC chip tend to be larger environments, more storage arrays. That means more software, more cost, reoccurring operational costs, and more staff to manage that. Remote copy. Remote copy means I'm copying stuff either within my data center to another storage array or to a geographically dispersed storage array. I need the ability to boot solid state drive technology, right? I need some form of management over the environment. I need some form of inline deduplication. I want to deduplicate as data comes in. I want to make sure that it's right there being done on the chip. I want some form of zero reclamation occurring within my environment, so that when I delete files, all those zeros that tend to get lost and cost me storage capacity, I want to be able to reclaim those. And I want to be able to do that coupled with thin provisioning, not as a thin provisioning bolt-on or bolt-in or some third-party application that's doing it for your storage array, but built into the core, native to the storage array. I want to be able to do provisioning of some sort. Thin and fat, I want to do it without disrupting any of the other services that are occurring within my storage array. And I want to be able to do some sort of connectivity so that I can have multiple storage arrays and be able to link all those together. There's so much to talk about when we didn't talk about RAID operations. We didn't talk about horizontal scalability and how we get a storage array through an ATO process. All of that are in other videos, but these 7 should get you started. I just want you to leave with this thought. Look at the 7 items on this screen. All 7 of them have to be done. In your storage array today, how is that work being accomplished? If you're able to divide and conquer between storage controllers and ASIC, I promise you that your performance will be faster, your cost will be lower, and the amount of arrays to do the same amount of work will be less with an ASIC chip.